Okay, so I want you to write down on your whiteboards, if you can remember them without looking, 3 things that functions and their inverse functions have, or ways that you could tell. Yeah, what you have is the way you can tell if it has a function as an inverse, but there are 3 other things that a function shared with its inverse, or 3 things that characteristics that it had to do with, like, their data points, their graph, what their graph looked like, what their data looked like I said. Okay, then their compositions. Remember, you could compose them, that kind of thing. And I'll go close the door. Y'all need to be quiet in the hallway. And yes.
If you have a function like this, the inverse was always if you switch the sign here and then put x minus 1. 3, that would be the inverse. That was just
okay, because the first thing you did when you start with this is you multiply by 3 and then you add 1. So you got to go in that order. You got to subtract 1 and then divide by 3. So that's correct, but we're going to find another way to find it besides just kind of guessing like that. Well, so there we are. You got your whiteboard. We're answering this question up here. 3 characteristics that functions and their inverses have, like something that has to do with the graph when you graph them both together, something that has to do with the data table, and something that has to do with their compositions. See if you can remember all 3. Let's see what you got. Good, good. That's kind of the same as this.
Oh, okay.
Just a different way of saying it. Can you remember from yesterday? You can, okay, try 1. No, that has to do with fun. No, good try. Why don't y'all look in your book, see if you can find it, section 1.9. Well, look in your book, section 1.9. Page 84 to 86. We didn't get as far as 87 yet. While y'all do that, I will take roll. What'd you get? Oh, okay. Find anything? Ah, nice. Yeah. A reflection. Because you got a function graph and you have an inverse graph. So which graph do you mean? Okay, see if you can find it in your book. Unless you have an answer, I'd rather you not mess with, you just keep the pen capped until you're ready. 1, 2, 3. Okay, Eddie, you found something? Help me out, buddy.
Something.
Okay, so several of you have found that the domain of the function is the range of the inverse and vice versa. The range of the function is the domain of the inverse, and vice versa. See if anybody's found some others besides you. You're on the right track. Yeah, inverse reflection of the function. Reflection, be more, a little bit more specific. Okay, the composition, that's kind of all one thing. Yeah, okay, a couple of y'all found that compositions of the function and its inverse. In other words, f of f negative 1 of x ends up giving you x, and same thing when you compose the original function with the inverse. Compositions yield x. I never. Okay. And what about the graph? Some of y'all are finding, you can kind of, they give a pictorial view on page 86 in the margin. You see some pictures. What are you seeing pictures of? I'm gonna put 3 up here. Graph, the graph of f is a reflection, right? Reflection of the inverse. Over what? Reflection over what is the mirror? The x-axis? The y-axis? So y equals x line. Remember that? That's a diagonal line. Okay, so those are characteristics that functions and their inverse functions have, because sometimes you'll be asked to identify if a function has a, if it has an inverse, what it looks like, or what the data looks like, or what the compositions do. These are ways you can prove that two functions are inverses. All right, you can put your markers away and your marker boards back. Tissue. Wow, just jumped out at me there. I'm losing my little nibs. No, they're all in there. Okay. Now, some of you are mentioning the fact that you have the horizontal line test. Okay, the horizontal line test tells you what? All right, the horizontal line tells you if the inverse function, or if the inverse is a function. Okay, and so if you have something like, nope, that's not going to work. That's going to fail. I was trying to think of one that would pass the vertical, the horizontal line test. Something like that. It passes the vertical line test, so we know it's a function. But if it passes the horizontal line test, is there anywhere that it's going to hit the line more than once? What? That's vertical line. Sorry. I knew that. Okay. Is there anywhere that a horizontal line will hit more than once? And if the answer is no, well, then you know that the inverse is a function. In fact, let me get purple over here. I need to go back to tracking. Okay. And so here's the y equals x line. And so, something like that would be a reflection of it over that line. And you can tell it is a function. And it also tells you if the function originally is a one-to-one function. One-to-one means that every x value corresponds to one y value. Sometimes when you have a function, we'll go with our good old parabola. A y value, you might find it at more than one x value. So you have, say you have -5 and 3, and you have 5 and 3. And so on your data points, you'll have -5, 3, and 5, 3. Okay, so you won't ever have one of the x's more than once, but you might have one of the y's more than once, and it can still be a function. Okay, but it's not one-to-one because 3 corresponds to 2 different numbers. So it's not one-to-one. But if it's one-to-one, only the y value, every y value only shows up once and every x value only shows up once. And then that also tells you that it passes the horizontal line test and that the inverse is a function. Catch all that? Okay, that's on page 87. The fancy way of saying what a one-to-one function is when each value of the dependent variable corresponds to exactly one value of the, oh, I read that wrong. When each value of the dependent variable corresponds to exactly one value of the independent variable, then the function f has an inverse function. Only if and only if f is one-to-one. Okay, so get your calculators out. And go to your y equals, clear it out. And let's do the checkpoint. It says A is f of x equals 1/2 parentheses 3 minus x. And we're supposed to find out if that function has an inverse function. So first of all, graph it and let's see what the graph looks like. Does it look linear? Everybody got it? It's not supposed to be following me. Okay, has a negative slope. Whoa, yours goes to the origin. That's 1/2, 3 minus x. Okay, do a zoom standard. That shouldn't make much difference. What? Yes, he did. And his 1/2 is in a fraction form, because that would give you 3/2 minus 1/2 x. So it should have a slope of -1/2, and it should go through the y-intercept.
Oh, hold on, put the 1/2 in parentheses.
But I figured if it was in that form, that it would know that it's a fraction. Now it's working. I really didn't know you needed to do that.
You know,
I just thought if it was a slanted thing, you had to.
It'll convert 1 divided by 2 times everything else that you done.
It'll say 1 divided by 2
Times x minus 3x. Or the 2 being multiplied by the 2 multiplied.
Possibly, yeah. So did you get it?
Okay.
Yep, yeah, okay. So does that look like it's got a inverse that's also a function? Yeah, okay, well what I want you to do now is go to the XY, go to the data table.
oh, now they're templates. Wait, hang on.
Oh, okay, yeah. And now it's working. Creepy. It was trying to get away with, I don't know. Yeah, that's weird. Okay, so go to the data table and you should notice that none of the x values or the y values repeat. Yeah, go to the data table. Okay, so that's what they're trying to get you to look at there. So it has an inverse function. Now, you've got it graphed. It looks something kind of like this, right? Maybe it's a little not that steep. It depends on your scale. And so if you think of the y equals x line, it's kind of hard for me to picture what that would look like reflected, kind of like this, I guess, kind of. I don't know. But we're going to find a good way to figure that out. Okay, so flip the page, finding the inverse function algebraically. Now, you'll have formula sheets, right? If you want to write these steps on your formula sheet, I think it would be a good idea. Although it's not a hard process to remember, you may feel like you don't really need it on your formula sheet. And these are the steps. Oh, that's a better. See if I can get this to track me now. Really annoying. Steps to finding the inverse function algebraically. Do you know how to spell algebraically? Okay, you could just say using math. And so the first thing they tell you to do is use the horizontal line test just to make sure it has an inverse, because you don't want to go through all this trouble if it doesn't have an inverse function. Okay, so use horizontal line test. To see if it has an inverse function. Okay. And if it does, then you'll start with the steps of actually finding it. And so change f of x to y, because f of x means y anyway, right? So if it says f of x equals blah, 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 change it to y equals blah, blah, blah. Then switch x and y. And then for solve for y. These are the main steps right here. And then 5, they throw a 5th step in just to tell you to verify using composition. Just you want to check your work. Some of y'all are really cautious. You want to check your work. Verify using the composition. Composition. You know, f of the other one. Okay, so let's give this a try. The one we had a minute ago, let's start from the beginning. F of x was 1/2 3 minus x, right? Okay, and so we looked at it and we saw vertical line test, horizontal line test, it should have a function. So it should have a inverse function. They all have inverses, but it's whether or not it's a function that we gotta figure out. So now I'm going to write it like this. Okay, no big change. Now I'm going to switch the x and y. I'm going to leave everything the same except y becomes an x and the x becomes a y. Okay, my robot, sorry. Yeah, he was snoring earlier. And it kind of makes sense that you would switch the x and y, right? Because we said that in the data table, aren't the x's and y's all switched? Okay, so now we got to solve for y. So what would be the first thing to do, the easiest thing to do to solve for y? How many of y'all want to distribute the 1/2? No, don't do that. It'd be easier to just multiply both sides by 2 first, okay? Okay, so I'm gonna multiply by 2 and by 2. So that 2 is just gonna totally get rid of my 1/2. So I'll have 2x equals 3 minus y. I'm trying to get y by itself. So I'm going to move y over so it becomes positive. And I'm going to move 2x to the other side to get it in the y equals mx plus b form, since I know it's linear. So 2x is going to be negative on this side. And then my 3 is on this side. It's positive, so I'll leave it like that. So I got y equals negative 2x plus 3. Oh, and then they do tell you to replace, let's see, replace, interchange. And so they make 2 of my steps into 1 step, and then they add replacing it with f to the negative 1. So this y now becomes f to the negative 1 of x equals negative 2x plus 3. So you can see this function and this function are inverses. So now go to y equals and plug this in and see if it's reflected over the y equals x line. You may have to type in y equals x so you can make sure. The step here was to use the composition of functions, but we'll just look at it. What does it look like? Remember, it also is more believable if you have it on Zoom Square, because the scales will be equal. The first one, you got a small scale. Yeah, that looks like it's going to do it. You should shoot it right through the intersection. What happened?
Why
don't you do the standard window? Maybe if you sit next to Mr. Smith, he can help you when you get stuck on stuff. Or at least keep you motivated to keep going. You don't put a negative 1 by the f of x. No, you just.
That's the negative.
Okay, what's the original one? Remember the original?
Plus 6? Oh,
The original is 1/2 3 minus x.
there we go. That?
Okay, you need
Minus x?
minus 2x plus 3, negative 2x plus 3, and then the original one also.
Oh, original 2. Okay.
Yeah.
So 1 over 2.
3 minus x.
What is that? That's the wrong one. 3 minus x.
Yeah. Okay, and then you might want to put a third function in the y equals x line, because that's the one that's supposed to reflect over. Okay, y'all ready for a trickier one? I'm going to do one on the board because the next one, look at that, the example 6, it has 2 x's. So that's not one you could look at and just kind of imagine what the inverse would be, like we did earlier, like when you said y equals 1/3 x. Oh, well, then y equals 3x is the reverse. Those were easy, but this one's a little trickier. So it is f of x equals 5 minus x on top and 3x plus 2 on the bottom. Okay, so I guess we need to see if that's going to pass the horizontal line test. Can you put that in your calculator for me? And put the numerator in parentheses and put divide and put the denominator in parentheses. Hopefully that'll make sure you get an accurate graph. It'll probably look something like, and yeah, something kind of like this. Got asymptotes, but the asymptotes are not the axes. They're like a little bit over and down. Everybody get something like that? Okay, does that pass the horizontal line test? As far as you can tell? Yeah? Okay. Yeah, you got it. Okay, so yeah, it looks like it does pass the vertical line, I mean the horizontal line test. So let's try out the steps. So we're gonna write y equals f minus x over 3x plus 2. And then I'm going to switch the x and y's. So y becomes x, 5 minus y, 3y plus 2. You remember doing this last year? Probably, you might not have got to it because of COVID. I don't know. Okay, now what do I do here to get y by itself? What would you do algebraically? We got y in 2 places. But how can we get rid of the dividing line? Can you think of this as maybe a fraction? Does that help? What are those magic words? Cross multiply? Yeah. Okay, remember, this is something that people get confused. Sometimes they think if you're supposed to, if you're multiplying 2 fractions, that you're supposed to cross multiply. But when you're multiplying, and so I'll put little times here, you go straight across, right, with fractions. So when the x is in the middle, you go straight across, okay? But if you have a fraction equal to another fraction, then you cross multiply, okay? And so if you have equal signs in the middle, you got an x out here. Here you have an equal sign out here and an x there. See, isn't that pretty cool? Little pattern there. Okay, so this is crisscross. So I'm gonna say this is equal to this. And so x times 3y plus 2 equals 1 times 5 minus y. So I don't really need the 1. Then I'm going to distribute. 3xy plus 2x equals 5 minus y. Blah. I changed them both, didn't I? Yes. Yeah, that's what they did. They collect the terms with the y, because you're interested in getting y by itself. So what we're going to do is get the terms that have y on one side of the equation and the other terms on the other side. Then we can factor that y out, okay? And so I'm going to leave 3xy here, but I'm going to add y to both sides, okay? And I'm going to subtract 2x from both sides. Okay, so that's going to cross out, that'll cross out. So I'll have 3xy plus y equals 5 minus 2x. My 5s today are dysfunctional. Okay. There you go. Now see, I can take this y out here like this, 3x plus 1. And that's going too low for my camera. Okay, I'm going to, that was already too low. There we go. Candace is coming to campus to get her picture taken after everybody else is finished. That's how they're doing the virtual students. They're having them. I thought they were going to take it over the camera or something. So she can't. She's not here. She's on the road. So she's going to be using the recording. Okay, so we had 3xy plus y equals 5 minus 2x. Then we factor the y out. That y is going to undistribute. And get 3x plus 1, 5 minus 2x. Then what's the last step? Get y by itself? Divide, right? Okay, this whole thing here. And so that will cancel, and you'll have y equals 5 minus 2x, 3x plus 1. And so if you want to see what this is as a reflection over the y-axis, you can graph that. Is that what they got? 5 minus 2x, 3x plus 1, yes. Now they say to do a composition. I think f, oh, we're supposed to change this one last step here, right? F to the negative 1 of x, 5 minus 2x. Can you imagine doing a composition of this? Means you'd have to put this fraction right here for this x and this fraction right here for this x. So you'd have a fraction in the numerator and a fraction in the denominator. You'd have to simplify all that. We'll just look at it on the graph. Did you graph it?
Mm-hmm.
Both of them? And they kind of, whoa. They kind of went over the same thing.
Mm-hmm.
They are different. How about if you zoom in? I wonder if they're different when you zoom in. Oh, this will help. It's like they're slightly different, right? I want to see one with the color. Oh,
I think I
come look at his and see if y'all did the same
put
thing.
them in.
Yeah, okay. See how his is?
Oh,
Hers are like almost overlapping. Go back to your y equals and make sure we put them both in the same way. 5 minus 2x, 3x plus 1. And what's your window? Is it a 16 and 10? What's your window? About the same. Whoa, something doesn't look right then, if you're asking me. What does yours look like? Well, hers looks a little different. Yours, okay, your scale, you're zoomed in. I think you can tell difference because hers is zoomed in, and so it shows up better when it's zoomed in. See, yours is what hers is looking like. And so if we went to the window and did a -5 to 5, -5 to 5, and graph. See, you can see they're slightly different. Yeah, it was just harder to see, but it shows up real well. I don't know, I think yours must be off a little bit though, to be that different.
Yeah.
Okay, let's see what you, or did you, no, you didn't have it zoomed in. Eddie, how'd yours look? Yeah, yours is closer. I mean, you can see the difference, but not as much of a difference. There must be something off with yours. Let me see your y equals. You may just have a possessed calculator. Y minus x, 3x plus 2. Oh, this is supposed to be a plus 2 in the denominator. Okay, we figured it out. Okay, so y'all go to the whiteboard. You're going to have one similar to this. Take your calculator with you. Okay, so you have f of x equals 5 minus 3x over x plus 2. So first you got to see, does it have an inverse function? So graph it and use the horizontal line test. I'm going to try it too here. Y equals, wow, I have a, and kind of thing. Check on number 1. If I were to judge by the graph, it does look like it does, right? Pass it. Okay, then we're going to change it to y equals all that stuff. And then we're going to change x to y and y to x. And then you're going to cross multiply. Make your x over 1 if you need to. Okay, so let's 3 and solve. Okay, so xy plus 2x equals 5 minus 3y. And then I'm going to move this over here, this over there. So that would give me xy plus 3y equals 5 minus 2x. And I'm getting too low. Five minus 2x over x plus 3.
5 minus 2x over.
X plus 3.
Oh, that's the final one?
That's the final one. So now I need to write it as f to the negative 1.
It's like, it's 5 minus 3x over x plus 2.
To begin with, it's I know, it's weird.
For a second.
And I guess when they're like that, their reflections are very similar to themselves. Yeah, because you're looking. Yeah, I think so. Do you check it out with his graph? Okay, you're going to do another one. Did everybody get it? We did the checkpoint on the bottom of page 88. We're about to start the one on page 89. Okay, try the next one, which is f of x equal the square root of 2x minus 3. So first, we have to check the graph. What you doing, James? You gonna do one of these up here? Yeah, get your calculator. Good. Looks kind of like so. Yep. Check. If you look at the data table, it actually is at 2, 1. Let's see. Something like that. Okay. How can a reflection be what?
It's a fraction because the x squared would like.
Well, the original one right here it would not pass a horizontal line test, right? And so it's actually only just that part of it, just part of it from the y-axis up.
So we have that thing we learned yesterday.
With the domain. So slash or divide by parentheses x greater than, so second test, greater than 0, greater than or equal to 0. Go to second and then the math button. Greater than or equal to 0. I guess that's probably, yeah. Negative 2y equals x squared minus 3. Y equals x squared minus plus 3 over 2. Do you have x squared plus 3 over 2? Yeah.
There's noise in you. I didn't have negative 2y.
I'm sorry? 2y, it was positive over here, so I brought it over here and it became negative. You probably did it a different.
I just didn't move.
Did everybody get x squared plus 3 over 2?
Both of my equations.
You'll need to calm down over there.
Yeah, little rowdy boys. What's going on? X squared plus 3. All right, you can go sit down. Nope, don't sit down. I got one more for you. But James, why don't you come over here where there's more room? I'll let you do it right here for the camera.
Well, yeah, but red doesn't make any difference.
James,
Yes.
over here.
I'm erasing.
And use this marker so it'll show up good on the camera. And then you got to write legibly too. Okay, so f of x equals the cubed root of 10 plus x. Okay, neatly. Oh, I need to move the camera over here so it can see you. And then get it to freeze. There. So have you kind of memorized the steps? They're pretty easy, right? Can you imagine what that function looks like without graphing it? It's the x cubed that's been moved how?
My hand is.
Moved what? Up, down? What'd you do? Up or down? I saw some hand motion. So minus 10 would be down.
Okay,
It
so
would,
I went like that.
oh, okay. That's kind of a weird gesture there. I think I just saw your hand coming back down again.
Oh, I went.
Yeah. Uh-oh, what's the matter?
Oh, I'm just slow.
Okay. Oh, okay. But you know what to do?
Yes.
Change f of x to y.
Wait, can I see?
And so, let me see your marker.
Never mind. You're good.
So this one is like that, where that's 10. And this one is a cube. Oh, I don't know how to do
Wouldn't that
cube.
be
I know
negative
square root. Oh, she did say up. It's wait, I see a minus and I see a plus. What is it? Minus or plus?
Minus.
It is minus. So it gets moved down. Miley, I was wrong. It does get moved down to 10 because it's minus. I was looking at Rebecca, Jesse's. Jessica, what happened? So what is that across the, probably something like
Crosses my line.
that. Whew, not bad.
Here's what I got.
Yeah. All righty, guys, have a seat. You ready to have a seat?
I know.
Jesse, you figure out what happened with your plus minus thing? Did you figure out what happened? Because it was minus 10.
Yes, I have.
You had minus 10? Okay. I thought I saw a plus sign. I don't know. I know, yeah. Okay. So look on page 89 for a second. Page 89. Kylie, did you get it? I wasn't following all the way. Did you get it all? Yeah. Okay, page 89, it says, state the definition. And to summarize, you got to be able to state the definition of an inverse function. Do you remember what the definition was? Oh, there we go. 85. It's kind of weird. It says that f of g of x equal x for every x in the domain of g, and that f of g of f of x equal x for every x in the domain of f. That's a weird way of saying it, right? It does kind of show that the compositions would be equal to x. I like saying that they're reflections of each other over the x, y equals x line. Or you could say a function that, an inverse is a function that undoes the original function. Okay. And then you have to be able to explain how to use the graph of a function to determine whether the function has an inverse function. We're using the reflection again, and then explain how to use a horizontal line test. We did that. And how to find it algebraically. So the assignment, and after we do the assignment in the back of the book, we'll do the organizer handout, the success organizer. And so the assignment is, be sure and put this section on your paper. Just put it as soon as you start. 1 through 6 all, those are the fill in the blank. 7 through 27 odd, 33 through 47, 63 and 69. And all of those are odds only. Now that's tricky to get, how to get this to show the board without my head being in the way. There. Yeah. So we'll go ahead and work the rest of the period on that. And we'll work on this tomorrow in class as well. We will start section 110 on Friday, which will be the last class before the pep rally, so-called. No, you have a long elective. The schedule, she texted that to us. I think it's the usual.
I mean, like the pep rally thing cuts us off 20 minutes.
Hang on. Oh, she emailed it. They may update it. Says your elective will be from 11 to 12:35. So that's 95 minutes on Friday. What the way that they're shortening it is there won't be house. So all your classes, academic classes, are pretty much the same size except maybe pre-cal, because according to the original schedule, it looks like it's only 30 minutes. 11 to 12:35. Yeah. Lunch 30 minutes and then third and fourth. So we'll see. Things can change between now and then. You can probably fill in all those blanks without even looking, right? Yes. Yes. Let it roll. Oh, and I think what I'm going to do is go get a photocopy for 17 and 19 so you can sketch on the photocopy and not have to redraw it yourself. I don't think there's anything else. Yes, that looks good. So. If you can do 17 and 19, just right there. Without having to redraw it.